Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem 3 sum closest. But before we get started, if you're liking these videos, please subscribe to the channel. When you subscribe to the channel, it lets me know that you want me to make more of these videos. And also, today we're going to solve this problem using the coding pattern called 2-pointers. If you want to find more videos where I solve Leetcode problems using the 2-pointers pattern, then please look in the video description. I provided a link to a playlist of all my 2-pointers videos. And then next, I'm going to solve this problem today using both Java and Python. So if you watch this video and I show, once you pass the part where I show how to solve the problem, if you want to skip to the Python part instead of the Java part, just look in the video description. You'll see the time codes, and that will let you click on the link to go straight to the different sections of the video. Okay, let's get started. So given an integer array nums of length n and an integer target, find 3 integers in nums such that the sum is closest to target. Return the sum of the 3 integers. You may assume that each input would have exactly one solution. Okay, so in this example here, we can see that when we sum certain values, we want to try to sum these up to get to -1, the closest. So the closest sum that we can find in here, to +1, I mean, is going to be 2. So, and we can see that these ones right here would be the closest. Okay, and then if, these are all zeros, so the closest is going to be 0. Let's look at the constraints. The constraints guarantee that there's going to be 3, so we don't have to worry about checking for nulls or checking to see if we'll have enough values in the array to be able to test for 3 sums. And the length is only 500. Okay, so that kind of tips us off that maybe this problem is going to take a bigger, big O time complexity. It's just, a hint. We'll figure that out as we analyze the problem, if that's the case or not. Next is the values in nums. They're between 1,000 to -1,000. So those are pretty small. We know if we sum up like the greatest of those, which would be 3,000, then that's going to fit in an integer. So that's good to know. Okay, next is target is between -10⁴ to 10⁴. Okay, so we're dealing with numbers where if we have to define, like in Java, we have to define what kind of data type we're using. We know we're going to be safe with using an integer to keep track of the sum. In Python, you don't have to worry about that. Anyway, so let's head over to the blackboard and we'll start solving this problem. Okay, so here is the example 1 problem. So if you watch my other videos in the 2-pointers playlist, you'll recognize this 3-sum problem. There's a couple of them on Leetcode. There's 2-sum, there's 3-sum, there's 4-sum, and then there's like variations of those. Here's a variation. We're working on a variation of 3-sum. We know that when we're working on these types of problems, we know there's like a coding template we kind of came up with. You'll see the similarities, but first we want to ask ourselves, like, what are they wanting us to do? They don't want us to return the indexes. So because of that, we know that we could, we don't have to keep the order of the values that they gave us this in. So since that's the case, let's go ahead and sort it. It's going to make our life easier if we sort this, because then we'll be able to, when we're trying to figure out what the closest sum is, we'll know like where the greater values are and where the smaller values are. So I'm going to copy this, and then we'll just start sorting. Whoop, yeah. Missed one. Okay, so now that's sorted. All right, next. What we're going to do next is let's look at the equation that we're dealing with here. So we have some target, and we want that to equal the sum of like three things. These are my index names. Okay, so what I could do is I could rearrange this equation to make this be a two-sum problem. So we'll go like this. Okay, now we have like a nice, easy two-sum problem. So then I'm going to drop down some indexes here. So that will be that index. This is my my left. This is my right. You know what? I'll just go ahead and write that over here too, just to kind of keep it consistent. If you are just glancing over here, make it easier to see. Okay, so when we're looking at this, our target, let's write down our target. So target, let's go with this color. Target is 2. Okay, so then when we're solving this, okay, so here's the idea. So we're going to start this I here at the beginning, and then we'll start a, so we're going to have one loop that's going to start from here and go out to here and stop there and won't go any farther because we need enough space to check 3 items. So as long as the I is less than nums.length minus 2. And then what we're going to do is every time for each iteration of I, we're going to put L at 1 plus I and then R at the end. And then when we do our sum here, we know if the value if it is too big, then we'll reduce the big number to be smaller. So here, let me show real quick. And then if it's too small, we'll reduce the small number to be bigger. So let me show that real quick. So we have this target. And we said that, let me move this down so that pop-up doesn't cover our equation. So we had target minus, and then this is like the -4, right? Equals, and then we have the -1 plus 2. So then we have, and our target was 2. So we have 2 plus 4 equals -2 plus that, which is 6 equals 1. Okay, so we have 6 equals 1, and so this number needs to get bigger. So because, but let's keep track so far. So our, we'll say our minimum difference. So our current minimum difference between, and it's going to be the, this is how we'll do it, like, actually, let's first we'll calculate our diff, like our current diff, right? So we're going to have the absolute value of the current target minus that, so which is 6 minus 1, so of what we calculated. So that is 5. So that's our current minimum diff, which is 5. Okay, but we want this to be closer to 0, so we need this 1 to be bigger. So we know, since we sorted this, that the bigger numbers are at the end on the right. So we'll move this up 1, and then we'll recalculate. So that -1 becomes a 1. Okay. All right, looking better. So it'd be nice if that's bigger, closer to 6. So we'll move this up. And look, it's the same number. We would redo it, you know. It's fine. It's not gonna change the big O when we recalculate like that. We're gonna iterate over it. But our minimum diff right now is 3. So, and then when we go like that, now that's going to end the loop. So I'll move these off here because they no longer exist, and we're in the outer loop now. We're going to move this forward 1, and then we'll put this at I plus 1 and that at the end, and then we'll recalculate. So now we have that's that, and then this is 1 plus 2, and so then we have 2 plus 1 equals 1 plus 2, which is 3 equals 3. Ooh, that's nice. So we're going to have 3 minus 3, which is 0, which is much better than that minimum diff. And so then, and we're keeping, one thing we have to do is we need to keep track of these indexes when we update our minimum diff. We need to update where those indexes were from so that we can provide the final solution in the end, because the final solution in the end is going to be the sum of these items. So we'll say that 1, 2, and 4. Okay, so 1, 2, and 4. So if this is the case, I mean, we can just end like we have a minimum diff of 0. We can't get any better than that. So we could just, we'll just break out of the inner loop and we'll break out of the outer loop, and that will be our answer. Okay, then let's hop over to the Java. All right, so here we go. I'm going to do this in both Java and Python. So if you want to skip to the Python one, the timecode is in the video description to click on to go to the Python version. Okay, so when we do this, let's see, we need to, first we said we had to sort the array. Let's see if I can make this bigger for you guys. There we go. First, we're going to sort the array, okay? And then the next, we're keeping track of the smallest diff. So let's start that value to be like the greatest possible value. So we just our starting sum value we know is not going to be valid, that we're going to end up replacing. Okay, so and then we got to keep track of the indexes we said. So we have indexes. We'll just start these out at values that don't make sense. Just our initial values here. Okay, and then we're going to iterate over this array. And remember, we said we had to stop at 2 prior because we need to have enough values to do 3 of them. Nums minus length subtracted by 2. That will be this will be the last one here. And then we could do, so when you look at my previous 2 pointers playlist problems, you'll know that there's this trick where you can avoid rechecking things like, so let me explain. So look at this here. This scenario, -1 plus 1 plus 2, okay? So I'm going to just write this down here. So we have -1 plus 1 plus 2. Okay, there's one scenario we checked just now, right? And this would go all the way down to here. And then when that's done, then we go to the next loop iteration, and that goes to the beginning, and that goes to the front. Look, we're about to redo it again. -1 plus 1 plus 2. So here's the trick. So first off, with your I, you do this with the outer loop. If you're at the beginning, it's okay, you just do it. But if you're not at the beginning, then if the value that you're currently looking at is the same as the value of the previous, then you're about to recheck things you already checked in the past. So you're going to skip this one. You're just going to go over here. Okay, so let's write that check. Okay, and then I said we can reduce this down to a two-sum problem. So we're going to do that. We're going to say two-sum. And then remember how we rearranged this here where we had this equation and we brought the nums of I over to the left, so it's target minus nums of I. So we'll do that. And then we said we're going to create a left pointer, which is going to be I plus 1. And then we got to pass in that smallest diff. And then we got to pass in the indexes array and the nums array. We got to keep track of the smallest diff, so we're going to assign it to be that. And then we also said, like, if that smallest diff ends up being 0, which we found an exact match, we break the outer loop, and we're also going to break the inner loop, which is going to be in this two sums problem. So here we go. Two sum. I'm going to call it start index instead of left here because I'll need to know, if we find a solution, I'll need to know this original value. And so you'll see in a second here. Okay, I can't stand that going off the screen there, so there we go. All right, so here's my left. So my left is going to be where the starts out where the start index is. Okay, and then my right is going to be at the end of the array. And then we're going to keep on doing this while the left is less than the right. Then we'll calculate our sum. And then we're going to calculate our current diff here. And then if the current diff is less than the smallest diff, then we'll update the smallest diff to be the current diff. And then we're also going to do some extra other work here. So indexes of I equals. Okay, so now when we pass this in, we want the I here. We just found the solution. We want the I. So I plus 1 is the start index. So we're going to say start index minus 1 to get us back to the I. And then we'll get the other ones. This is going to be our left, and this is our right. Those are our indexes. Okay. Now, if we are the case where this, you could say current diff equals 0, or you could say target equals sum. I guess since we'll just say current diff equals 0, since that's what I wrote in the blackboard. Okay, if that's the case, then we're going to return the smallest diff. Just copy this. Else, if the sum is greater than the target, then you know what? I'm gonna say, since I'm gonna say sum and target down here, I'm gonna make the code be a little more readable. So there we go. Sum greater than the target, then right minus minus. Else, if sum is less than the target, left plus plus. And then, this is the only other case that could happen, so you could just say else if you wanted to. But I wanted to write it out so that it's better for teaching. Okay, so, and then we have to return something still. So we have our smallest diff, right? So that's what we're updating. That's what we need to keep track of so we can pass back in on the next one. So, okay, so let's run that. Oh, oops. I went a little too fast, sorry. So now that we have these indexes, we got to return the sum. So at nums, we know where the indexes are now that have that answer. So that's at 0 plus nums of indexes of 1 plus nums of indexes of 2. Okay. Okay, great. And then we'll submit it. All right, and then it passed. So now we'll head over to the Python. Okay, so we said we're gonna sort these nums. Excuse me. Okay, and then we need our. Okay, so they're doing this camel case thing going on here. I guess I'll just follow the same style since I'm working in a code base that already decided it. So I usually like the underscores for Python, but all right. Now we need a value that's going to be bigger than what we need. We could do the max value by importing, or we could go down to the right down here, and we can also take a look at our bounds and decide on a value that's bigger than what could be possible. So if I was to do target is in that range, right? If I was to do 10 to the 5, that's going to be bigger than what we could ever find. The reason why I want to do that is because I want this to get replaced on the first thing we find. So just go like this. There we go. And then we'll do our indexes here. So we got to keep track of where those indexes of where the smallest values ended up being. I mean, where the solution is. So we'll just start out at that, and then we're going to go from I in range of um, length of the nums minus 2. And that was because remember that when we have this here, we need to have I stop at a location where there's enough to find 3 of them. Okay. And oh yeah. Next, we want to avoid checking um, answers that we already found in the past. So I set this scenario up here for us to see that. So look at this. So if we were to do this one, let's say we're right here, and we check to see -1 plus 1 plus 2, and then let's say we finish that loop, and then we go this next one here, and we're gonna check and look, we are checking the same thing again, -1 plus 1 plus 2. So to avoid doing extra work, rechecking things we already checked, what we'll do is this trick that that I showed in previous videos of my 2 pointers playlist. So first off, if we're at the beginning, I equals 0, that's fine. We just use it. But if we're not at the beginning, then we're going to check to see if the value is the same as the previous value. And if it is, we're going to skip that one because that would be a scenario where we end up doing the same work again. So we will write that. Okay, and then I said we can reduce this down to a 2-sums problem. So, and then in our equation, we took this equation here and we rearranged it by moving the nums to the left of the equal sign. So we have target minus nums minus 1. Target minus nums of I. And then we need to pass in that I. So we need when we are looping, right? So we're here. We need to put a left down 1 plus I. So we'll say I plus 1. And then also we need to pass in this smallest diff to keep track of the smallest diff. And then we need to pass in those indexes to keep track of where the solution is, and then the nums. And then if we encounter a situation where the diff was 0, then we found the solution, like the perfect solution. We don't have to look any farther. So we can break this outer for loop here. We can break this loop here. By saying if smallest diff equals 0, then break. And in here, inside the inner for loop, in our toSum function, where we will have another loop, we'll also break 2 if we end up having that scenario. So then we'll hop down here. Okay, and then in our toSum, we have the, whoops, that's our new target there, and then start index, and then the smallest diff, and then our indexes, and then our nums. So we'll make our left, which is going to be the start index, and then our right is the nums. So the length of our nums minus 1, and then okay, so here's our left. We got that left. We put the right over here at the end. And then we'll keep on looping while the left is less than the right. And then we're going to calculate our sum. And then we're going to check to see what the diff is. And then I'm going to call this current sum. Okay. All right, and then now we're going to check to see if the current diff is less than the smallest diff, and if that's the case, we'll update the smallest diff to equal the current diff, and then we're going to have these indexes. So the index, so we want this I, so I plus 1 is the start index, so we're going to say I minus 1 to get back to the I, and then do this, that's the left, this is the right. Okay, so this is the indexes of where we found a solution, because like what we're going to do after we finish all this is we'll have these indexes, and we're going to return the nums of where, when we're going to use those indexes to know where the numbers are that formed our solution. Okay. And then now we're going to check to see if the sum, if the current sum is equal to our target, then we found a perfect solution. So we'll just return the smallest diff. Else, if the sum is greater, the current sum is greater than the target, then we have a number that's too big, so we need to move the right down 1 because we have sorted it, so we know that the bigger numbers are at the end here, so go to the smaller number for our next check. Otherwise, if the current sum is less than the target, then we know that we need to move this left up 1. And this is the only other solution, so we could say else like that. And then once we finish this while loop, Then we want to return the smallest diff. Okay, so we'll run this. And then I didn't pass something in. Oh, oops. Self. Okay, and then we'll submit it. Okay, great. And we have a solution here. So, if you like these videos, please subscribe to the channel because that's how I get incentivized to make more of them. Also, if you want to see more two-pointers videos where I solve Leetcode problems using the two-pointer coding pattern, look in the video description for that playlist, and I will talk to you guys later.